All right, welcome back. We're looking at day 5, which is finishing up the kind of intro into rational functions and what we can figure out on our own before using a calculator. So first off, notice this one for number 3. It is a little bit different. The denominator is in quadratic form, so you always want to write your rational functions if you can. You always want to factor the numerator and factor the denominator. Numerator you can't, but your factors of x squared plus x minus 2 will be x plus 2 times x minus 1. And the reason is because if we can reduce or cancel a factor, we want to do that before continuing on. So remember what tells us our domain and what gives us our restrictions in our domain, and that is anywhere your denominator is 0. So if you set your denominator equal to 0, x plus 2 equal to 0, that means you have a vertical asymptote at x equals negative 2. And if you set x minus 1 equal to 0, that means you have a vertical asymptote at x equals 1. And so that actually happens here. You have vertical asymptotes at x equals negative 2 and x equals 1. So those are your breaks in your domain. So your domain will be negative infinity to negative 2, negative 2 to 1, and then 1 to positive infinity. Oh, that looks like an 8. Okay, so remember, how do we find our domain? It's anywhere, it's pretty much always going to be all real numbers unless your denominator equals, there's a place where it's undefined, and so we find that by setting our denominator equal to 0. Roots or zeros come from our numerator equaling 0, and so any factor you have, set that equal to 0, so that means we'll have an x-intercept of negative 1. Y-intercept, if you plug in 0 everywhere you have an x, you'll get 1 over negative 2. And then it says use a graphing calculator to sketch. Obviously, we can get some of this just by doing this part of it. We have a vertical asymptote at 1. We have a vertical asymptote at negative 2. And we know it's crossing the x-axis at negative 1. And you can get the rest of that by plugging it into your calculator. So go ahead and do that. So if you plug this into your calculator, this is what it should look like. If it doesn't, you may have plugged it in incorrectly. So remember, your denominator, especially your denominator, must be in parentheses when you put into y1, okay? Whether it's these outside parentheses in the factored form or not in factored form. So now looking at this, you can see our vertical asymptotes did show up. You don't actually see the dotted lines, but you can see your graph is approaching them. End behavior, remember that's talking about as x gets really small, what is y getting closer to? And as x gets really big, what is y getting closer to? And notice both of those are approaching our x-axis of y equals 0. So as x gets really small, y gets closer to 0, but from below the x-axis. As x gets really large, y gets closer to 0, but from above. Describe increasing. It never does increase, but it is decreasing the entire time. So notice as we go from left to right, it's decreasing, and it's decreasing. So it's decreasing everywhere except at our vertical asymptotes. So it's decreasing over the entire domain. So negative infinity to negative 2, negative 2 to 1, 1 to infinity. And then describe where the graph changes signs. So it's negative, 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 negative. Then up here it changes signs to positive. So it changes signs at vertical asymptote as well as x-intercept. And then again, it's negative, 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 changes sign at the asymptote, and it comes up positive. So I want you to try number 4 on your own and then check in. So go ahead and pause it. Okay, so this is what our graph looks like. Remember, your domain comes from your vertical asymptotes, and those come from where your denominator equals 0. So that kind of gives you your break And then your roots come from your numerator equaling 0. Y-intercept comes from plugging in 0 anywhere you have an x. There's your graph. So increasing and decreasing is a little bit tougher with this one because you do have some relative mins and maxes. I did find that relative min in between -1 and -5, and then there was a relative max, which you may not have realized it, and the only reason I knew that that had to be there was because there was an x-intercept there. So I knew in this region over here that if this was passing, it's going to come back and it's going to approach that x-axis. And you'll get to know that more as we work through rational functions. So if you didn't catch that there, not a huge deal. We will get better at that. Okay, so now go ahead and flip over to page 10 in your, not 10, page, I think it's page 12. Let's see, what number is it? Yeah, page 12 in your packet. And it's a summary of graphs of rational functions. And what I want you to do here is to go through and answer these questions and then check back and compare your answers to mine. Okay, here's the end filled out, so go ahead and check your answer. The only thing that we haven't talked about, which we'll get into tomorrow, or maybe the next day, is horizontal asymptotes, and if there's any shortcuts to finding them. The answer is yes, and we will talk about that coming up. So for now, it's kind of like you scroll on your calculator to the right as x gets big, or on your table and see what happens to your y value, or scroll to the left or in the negative direction on your table and see what happens with your y value. Okay?